All right, so I did this with the class already, but I didn't record, so I'm doing this specifically for you people who are absent. So this is the back page of 1.6. If you're given a graph like this, examine a graph to the right, which shows the approximate distance traveled or distance fallen by a parachutist in the first 5 seconds after jumping out. How fast was the parachutist traveling 2 seconds after the jump? So the question only gives you a graph. You only have your human eyes to solve for the average rate of change or even the instantaneous rate of change. Since they're asking for just 2 seconds, not between 0 and 2, you are asked to find the instantaneous rate of change at 2. What does that mean? It means using your abilities, you're going to have to draw a tangent line, something like that. Maybe I'll use a different color. Okay. For a tangent line, drawing a tangent line, something like that, that hits this point at 2. Okay. And from there, you have to find the rate of change of that tangent. Rate of change, AKA the slope. I need you to find the slope of this line, which happens to be how quickly we are dropping at that specific point in time. The way to find slope, remember, you need 2 points. And so I'm going to estimate 2 nice points on this graph. These are nice. So this is a 0.10, and that's a 0.460. It seems all right. So what is the slope of that? Again, I'll write it down here so that you can see. 0.4060 is 1 point. 1, 0 is another. So instantaneous rate of change at 2 seconds is going to be 64 minus 0, 1 equals 60 over 3, which is 20. At 2 seconds, I'm going to estimate at the rate of change of the distance is 20 meters per second. Okay, I have increased my distance traveled by 20 meters every second at that point. Right? Instead of a graph, if the question happens to give you a data chart, data table, like the one here. So I'm going to clear this. So if you want to pause the video to copy it down, you can. Right? If the question gives you a data sheet, well, they give you time 20. We want to have as close of a smallest interval possible. So the table that below represents distance between gained by the parachutist from example 1 in 0.5 second intervals. We want the interval to be smaller than what we had before. And the smallest interval that we can do safely right now is 0.5 seconds. So I'm going to say, let's use the variables here. Distance at 2 seconds is going to be 20.00. The distance at 2.5 seconds, which is the next next closest number, point, is going to be 31.25. And so the instantaneous rate of change based on what we're given is going to be, unfortunately, an interval between 20 to 22.5, which is, so the interval at 2 is delta y over delta t x, which is in this case delta b over delta t, okay, is going to be 31.25 at an x value of minus 20.00 with an x value of 11.25 over 0.5. And that will be 22.50. So again, I think this is a bit more accurate. The rate of change at 2 seconds is approximated to be 22.5 meters per second. Now, the third example, which is going to be most useful for your in-class assignment, I'm emailing to you. It is going to be right there. All right, so this is an equation for the graph in example 1. This is the equation for the data table in example 2. If they ask for at exactly 2 seconds, that means, again, they are looking for IROC, and the interval, right, to calculate the instantaneous is going to be a interval of 0.001 seconds, as we talked about in class. So what is d of 2? Well, 5 times 2 squared is going to be 20. What is d of 2.001? I need a calculator, so bear with me. Yeah. That's not nice.
No offense, you're not a mathematician, Mr. Kim, it's okay.
What? What?
Aren't you more science?
Oh my gosh, stop. Stop this. All right, putting this together, IROC is going to be, oh, this is actually another shameless plug into calculus and vectors. Calculus and vectors, the heart of calculus and vectors, your baby steps will start with this. They will give you a formula very similar. So IROC in this case is going to be, remember, it's delta y over delta x, right? So what is the y value at 2.001? And what is the x value? Well, 2.001 minus, what is the y value of 2 seconds? And what's the x value? 2 seconds. That is 20.02005 minus 20 over 2.001 minus 2. This brings us to that over this. Plug that into the calculator, you should get 20.05 meters per second. There it is. So using this formula with the average interval of 0.001 seconds, which is instantaneous, the rate of change is 20.05 meters per second. Well, that's going to help you when you do your rate of change assignment. I'm going to go to the email and email you people now. If you can get it done today, that's great, but I know it's probably a religious holiday for a lot of you, so we'll talk tomorrow. Right? Hope it helps, and we'll see you in the next one.